Okay. Well, this is a webinar for waste characterization and listed hazardous wastes. This is a continuation of a few prior presentations we gave, all of which were basically the same content back in May and June of 2019 in Connecticut, Massachusetts, New Hampshire. And what we decided to do is to hold these webinars to go into greater detail on some of the subjects, the main subjects covered in that earlier face-to-face training. By the way, the slides from that face-to-face training back in May and June, all three sessions are available on the NUMOA website. There's a link for it later on in this presentation, and there's a few future webinars to come. I'll talk a little bit more about those later. Go ahead to the first slide. Okay, and you'll have to, okay. We're primarily going to be talking about characterization of contaminated environmental media during this webinar. And the main focus here will be on the federal hazardous waste regulations. But you also need to keep in mind that the state hazardous waste regulations are also an issue because they do vary from state to state, and states do have more stringent requirements. Although the state regulations tend to follow or track the federal hazardous waste regulations very closely on waste characterization, there are some differences that can vary from state to state, so be mindful of that. Also relevant here, beyond the hazardous waste regulations, are different solid waste requirements, which are pretty much state-specific and vary from state to state. Some states may regulate remediation-derived waste, particularly contaminated soil, as a quote-unquote special waste. And also, it's important to keep in mind that states may have remediation standard regulations that may apply and could have an impact on characterization or subsequent management of the waste. Most of the NUMOA states do have remediation standard regulations. 3 of the NUMOA states also license environmental professionals. Go ahead and go to the next slide, Terry. The issues we're going to go over today include the responsibilities of the generator for characterization, the point of generation, in other words, when waste is first subject to regulation, hazardous waste determinations, which is the process by which you determine whether or not a waste is hazardous, characteristic hazardous waste, which is one of 2 major categories of hazardous waste, the other being listed hazardous waste, and we're going to go into each of those in detail. Something called the contained-in principle that applies specifically to listed hazardous waste and plays a big part in the characterization of environmental media in particular. Also non-hazardous waste management requirements, some examples and case studies. And although it's not appearing here, Terry, I think you have to hit the button one more time for the last bullet to appear. We're also going to look at the importance of waste characterization as a part of overall project management. We really want to drive home the notion that waste characterization should be considered from the very beginning stages of a remedial project because it has so many effects on compliance with hazardous waste requirements, of course, but also just how the project itself will go. On to the next slide. So we're going to look at generator responsibilities. The first and most important responsibility of the generator is to fully and properly characterize the waste. Now, ultimately, this is the responsibility of the generator, not the transporter, the disposal facility, consultants, or other parties, although those parties may provide assistance and information, and that's fine as long as that information is correct. Ultimately, the responsibility falls on the generator. Subsequent to the process of characterizing the waste, which we call a hazardous waste determination, if the waste is hazardous, the generator has to manage it in accordance with all applicable hazardous waste requirements. And lastly, one thing I want to point out about the concept of who's the generator. EPA a long time ago clarified this issue and talks about what it refers to as co-generators. A co-generator is anyone other than, well, anyone really that meets the definition of generator in the hazardous waste regulations, which is a person who first generates a waste or causes it to become subject to regulation. And in some cases, this can include a number of different people. It could include a property owner and or the operator of the property, such as a lessee. It could include the remediation consultant, or it can include remediation or disposal contractors. If they have some sort of a role in the waste being generated or being subject to regulation, then they can be a co-generator. And the concept of joint and several liability means that a EPA or an authorized state could pursue enforcement against any one of the co-generators or any combination of the co-generators for failure to comply with the requirements for characterization or generator requirements. However, I'll also note that EPA has said, and at least in Connecticut we agree with this, you may want to check with your particular local state to see if this is the case. If there is a written agreement in place that specifies that a particular co-generator is responsible for complying with one or more of the generator requirements, then the enforcement agency would typically pursue enforcement against that party first in any situation where there's non-compliance. On to the next slide. Okay, so next we're going to talk about the point of generation, which is to say the point in time when a waste becomes hazardous waste and subject to the hazardous waste requirements. And there's a general principle at play here, which is very important when it comes to remediation wastes. And that is that a waste that's placed into storage or disposal prior to the effective date of RCRA for that particular waste is not a waste or a hazardous waste until it's removed from storage or disposal. Okay, I'm just going to quickly say that again. A waste that's placed into storage or disposal before the effective date of RCRA for that waste is not a waste or a hazardous waste until it's removed from storage or disposal. As a result of this general principle, environmental media such as soil, groundwater, or sediment that's contaminated with hazardous waste before the effective date of RCRA for the waste that contaminated it is not a hazardous waste as long as it's in the ground. Okay, so if the waste was generated, pre-RCRA and it's in the ground, it's not a waste where it sits, and it's not a hazardous waste either. However, as noted in the third bullet, once media is removed from the ground, removed from storage or disposal, and this could mean digging up soil or pumping out groundwater, it's generated at that point in time and becomes a waste. In addition, if it's characteristically hazardous or listed hazardous waste, it would be regulated as a hazardous waste. And in a minute, we'll talk more about what characteristic and listed hazardous waste means. Now, we're kind of focusing here on environmental media, but in addition to media, this principle also applies to other wastes that might be found at cleanup sites, such as buried drums, abandoned tanks that have contents in them, sludge remaining in old surface impoundments, basically any sort of waste that has been disposed of and before the effective date of RCRA. As with contaminated media, these other types of waste like buried drums and so forth become wastes and potentially hazardous wastes when they're removed from the ground. A couple of notes on this. The reason for all of this, the reason for this concept is that on the one hand, EPA didn't want to enforce RCRA requirements retroactively to historic disposal that may have been legal at the time that it occurred. In addition, this would have had the effect of basically making almost every contaminated site and landfill in the country subject to RCRA permitting. On the other hand, EPA did not want to extend this concept to wastes that were disposed of after RCRA because it would provide an incentive to dispose of these wastes illegally or release them to the ground. And that takes me to the next slide. I'll get into that a little bit more on the next slide. But the other thing I wanted to mention is with respect to hazardous waste listings in particular, the applicability of these listings is retroactive. So if a particular hazardous waste listing applies to a waste that was disposed of before, or put into storage or disposal before the listing became effective under RCRA, it becomes a hazardous waste meeting that listing at the point of generation. And we'll actually get into some examples that explain this a little bit better first. But just keep in mind that the hazardous waste listings, not the characteristics, but the listings are retroactive. Okay, so this concept of wastes that are disposed of prior to the effective date of RCRA or become hazardous waste when they're removed from storage or disposal does not apply to environmental media that was contaminated with hazardous waste after the effective date of RCRA for that waste. And again, the reason for this, as I mentioned, was EPA didn't want to provide an unintended incentive for people to intentionally dispose or spill wastes. Now, I keep mentioning the effective date of RCRA for the waste. What do I mean by that? In most cases, that's November 19th, 1980, because that was the effective date, the first effective date of RCRA, and most of the waste listed under RCRA as either characteristic or listed hazardous wastes existed in November 19th, 1980, but there are certain wastes that were added to the lists of hazardous wastes after November 19th, 1980. And a prominent example here is the volatile organic compounds and semi-volatile organic compounds on the TCLP list, which EPA did not add until March 29th, 1990. So for those wastes, TCLP, VOCs, and SVOCs, the effective date of RCRA would be March 29th, 1990. Therefore, if you had a waste that was characteristically hazardous for TCLP, SVOCs, or VOCs, and it's in the ground, it's not a hazardous waste until you excavate it, pick it up. The other important concept behind the point of generation is, as I sort of mentioned and alluded to earlier, is that that's the point in time when compliance with hazardous waste requirements must begin. And just that last bullet there, we want to reiterate, because this is a common misperception, that doesn't mean that compliance is required when the test results come back and confirm that something is hazardous. A waste is hazardous when it's generated, regardless of whether or not you know it's hazardous, not when the results come back and you know that it's hazardous. We'll actually get in a little further into the presentation to a discussion of how you deal with this issue, because it can be a difficult issue. Next slide. So, how does one figure out if a waste is hazardous or not? The process by which you do that is generally referred to as a hazardous waste determination. Can you advance the slide, Terry? So, it's a regulatory requirement of the hazardous waste requirements that a generator of a solid waste must determine if that waste is hazardous. And when I say solid waste, it doesn't have to be physically solid, it just has to meet the definition of solid waste in the hazardous waste regulations, which basically is just about anything that's discarded. Furthermore, the requirement to make the hazardous waste determination must occur at the point of generation. EPA recently clarified this point in the hazardous waste generator improvements rule, which not all of the NMOA states have picked up, but EPA did say that this was always their intent of the pre-existing regulations, and that the more recent changes, which may or may not have been picked up in all of the NMOA states, was really a clarification. So the existing regulations, the implication is that the determination of whether or not it's hazardous should occur at the point of generation. And performing a hazardous waste determination basically consists of answering a number of questions. First of all, is it a characteristically hazardous waste? Secondly, is it a listed hazardous waste? Third, might it be a state-listed hazardous waste? In some states, in the NMOA region, states have non-federal listed wastes. that you need to consider in addition to the federally listed characteristic and listed wastes. And as an extension on this, and other questions that come up are, which hazardous waste codes will apply to the waste? Each characteristically hazardous waste and listed hazardous waste has a unique EPA waste code that's associated with it, and that needs to be put on the manifest when it's shipped. So that's all part of the hazardous waste determination process. Another thing that is important in this process is determining whether a particular hazardous waste is an acute or non-acute hazardous waste. This is important because acute hazardous wastes are in some cases, well, first of all, they're called acute hazardous wastes because they're more intensely toxic than non-acute hazardous wastes. We call them the nastiest of the nasties. So they require great care in handling them to make sure that injuries and accidents don't occur, but also because they are subject to additional requirements, additional generator requirements. Now, how does one perform a hazardous waste determination? It can be performed through testing, and I would point out that any testing that's done for hazardous waste determinations has to be done using the appropriate EPA test methods as specified in the EPA Solid Waste Testing Manual, SW846. These are the 4-digit test methods like 8260 and 8270 that many of you are probably familiar with. In addition, when testing is used to perform a hazardous waste determination, it must be representative, the testing must be representative of the waste that is being removed and disposed of. And sometimes a single sample can achieve that goal. Other times it's necessary to take multiple samples to determine whether or not the waste is hazardous. In particular, if you're looking at soil over a widespread area, it may be necessary to set up some sort of a grid pattern to take samples on, and in some cases do composite sampling. I could do a whole session on how to sample for hazardous waste determination purposes, and maybe we can dive into that at some later date, but I'll just leave it at that. The alternative to testing for hazardous waste determination purposes is something called knowledge of process, or as is stated in the federal regulations, knowledge of the hazardous or the hazard characteristics of the waste in light of the materials and processes used. So this is basically information that you can find out about the waste through other sources other than testing. And it can include things like material safety data sheets that might indicate the contents and the ingredients in products used by a company that may have been spilled or released, product data sheets, product test data, purchasing records and other business records, safety records, employee interviews, and in some cases prior sampling. So for example, if you've got a site where you've got contaminated soil, and for remediation purposes, you have some mass analysis results from the soil, and in total, or a milligram per kilogram units. In some cases, you can use those to either make the determination or at least aid in the making of the determination. For example, if your total sampling reveals that there are 4 different metals present that are listed under the hazardous waste characteristic for toxicity, then you know that that's what you have to be looking for as potential hazardous waste constituents. In addition, there's something called the 20 times principle, which falls out of the fact that the TCLP test, which is used to determine whether or not a waste is characteristic, employs leaching media at a rate of 20 times the weight of the sample. So if you have soil that's sampled, let's say at 80 milligrams per kilogram of chromium, and you're trying to figure out if that soil is hazardous, you can just divide that 80 by 20, which gives you 4, and compare that number against the TCLP standard for that compound, which actually happens to be 5 milligrams per liter. And in that particular case, with 80 divided by 20 equals 4, you would have been able to show via mass analysis and knowledge of process that waste is non-hazardous because it can't possibly fail the TCLP. Again, that testing would have to be representative of the material being disposed of and would have had to have been done using appropriate test methods for RCRA purposes. Okay, let's advance to the next slide. Talk a little bit more about hazardous waste determinations. The hazardous waste determination process I just described can and should also be used for purposes of complying with the land disposal restrictions. We're going to have a separate webinar on the land disposal restrictions. They're quite complicated and they play a big part in the environmental and the management of environmental media. But suffice it to say that you can kind of double up when performing hazardous waste determinations and also satisfy some obligations that you have as a generator under the LDR requirements, particularly as it relates to what's referred to as underlying hazardous constituents, and also to in cases where you're trying to meet the LDR treatment standards for a waste that might allow you to send it to a solid waste landfill. The next issue here I wanted to bring up on hazardous waste determinations is something I alluded to earlier, which is how to handle unknowns. And when I speak of unknowns, I'm talking about things like unmarked drums or uncontained waste that are found at a cleanup site, or drums of drill cutting spoils or groundwater generated during site investigations. In some cases, it may be necessary to do testing to figure out whether or not these are hazardous, and if so, exactly what for. Our recommendation on handling unknowns is, if possible, try to characterize the material before it is generated. Now, it seems that, well, wait a minute, if it's an unknown, how can I possibly do that? Well, you know, if your waste stream is contaminated soil, and as I said before, you've done some sampling for remediation purposes for total metals, you might actually be able to make a determination before the stuff is actually generated as a waste. In some cases, it's simply not possible. If you're drilling a well, the cutting spoils and the well production groundwater have to go somewhere, and often that's into a drum, and they're generated. So it may not be possible to characterize them immediately at that time. Our advice on this, if they can't be characterized prior to generation, is to containerize them if they're not already containerized, sample them for hazardous waste determinations, mark them with a hazardous waste label like the one up in the right-hand corner, and under waste description put hazardous waste pending analysis, and just manage that container as a hazardous waste until the results come back. If the results come back hazardous, you're covered, although you may need to add the waste codes at that time to clarify what it is, or the description of the waste. You may also have to alter that on the label. If it comes back non-hazardous, you can just remove the hazardous waste label, put a non-hazardous waste label on, and identify it as appropriate. Let's move on to the next slide. Okay, so let's delve now into the different types of waste that can be hazardous and that require different types of questions that need to be answered in order to determine if they're hazardous. And the first general category is characteristic hazardous waste. And generally speaking, characteristic hazardous waste is a waste that exhibits a particular characteristic or physical property that makes it hazardous. And there's 4 of these properties. The first one is called ignitability, and you see there that it carries the EPA waste code D001. The second one is corrosivity, D002. The third one is reactivity, D003. And the fourth one is toxicity, which is constituent specific. And if you could hit the return button just one more time, Terry, to bring down the bullet underneath the last bullet. There are a number of compounds that are listed under the TCLP test, which is the test used to determine toxicity unless knowledge of process is used. And these 40 constituents include 8 RCRA metals, 10 VOCs, 14 SVOCs, and 8 pesticides and herbicides. Just jumping back a little bit to put a little finer point on it, a waste is ignitable if it's a liquid with a flash point below 140 degrees Fahrenheit. If it's an ignitable solid, an example of that could be, for example, sodium metal. If it's an ignitable compressed gas, or if it's a DOT oxidizer. A waste is corrosive if it has a pH less than or equal to 2, or greater than or equal to 12.5. There's also a provision by which if it corrodes steel at in excess of a certain rate as indicated by an SAE test, that it would also be corrosive. And wastes are reactive if they react with water, if they're explosive, and it also covers some cyanide and sulfide-bearing wastes. Let's go on to the next slide. So those are the wastes that are characteristically hazardous, and that applies to wastes as originally generated, but it also applies to contaminated environmental media that can contain these wastes as a result of disposal or a spill. However, a contaminated environmental media, and that could include soil, groundwater, or sediment, is only regulated as a characteristically hazardous waste if it actually exhibits the characteristic of the waste it's contaminated with. And of course, this is after the point of generation. We had a whole discussion earlier about at what point in time a waste is generated, and this concept only applies after the point of generation. So, for example, if you have a contaminated environmental media that contains lead from the spill of a lead plating waste, then it would be a characteristically hazardous waste if it fails the TCLP test, for example, for lead. I'll also talk about the possibility of some hazardous waste listings applying in that particular scenario, but we'll get to that in a second. There are some resources you can use to assess characteristically hazardous waste that are listed there. The fact that they're yellow means that they're hyperlinks, and Terry will be making this presentation available after this presentation, so you'll be able to access it and download it, and you'll have access to those particular documents that are listed there. One of them is called Managing Remediation Waste under RCRA, which is an excellent document, not just for characterization, but also for general management of remediation wastes under RCRA. The second one is an EPA document that is primarily focused on industrial wastes, but can also be used to provide assistance on determining whether or not a remediation-derived waste is characteristically hazardous. And the third resource is something called RCRA Online, which is an EPA database of regulatory interpretations. And you can go on that if you're trying to get help with a particular type of waste stream, insert certain keywords, do a search, and come up with documents where EPA may have spoken to that particular issue. Let's go on to the next slide. And the last slide having to do with characteristic hazardous wastes. At a practical level, the definition of ignitability, corrosivity, and reactivity, those particular characteristics anyway. Oh, you went a little too far, Terry. Thank you. Will often rule out media being hazardous waste for these three particular characteristics for a number of reasons. One of the reasons is that environmental media, in particular soil and sometimes sediment, are often solid, and the fact that they're solid as opposed to liquids makes, in particular, the ignitability and corrosivity characteristics unlikely, since each of those characteristics either requires the waste be a liquid in the first place, or that a waste that is solid is just not likely to express or exhibit that property of ignitability or corrosivity. Secondly, it's often the case that media, because they're primarily soil or sediment or water, just don't exhibit the properties that makes the waste hazardous in the first place. For example, just to kind of bring this one into the picture, reactivity, or as I like to call it, things that go boom. Generally, environmental media doesn't go boom. We did have a case in Connecticut at an explosive manufacturing facility where, unfortunately, a worker put a shovel into the ground and hit some old explosive material from World War I that resulted in an explosion and that actually killed the worker. So, you know, contaminated environmental media can be reactive, but it's very rare. Another thing I'll mention with characteristic hazardous wastes, even if you determine that it's not hazardous waste, there are circumstances where it may be still subject to certain RCRA requirements, in particular, the land disposal restrictions. This is particularly the case for wastes that are made non-hazardous through, for example, through in situ or ex situ treatment. And we'll get more into when LDRs and some of these other requirements come into play for non-hazardous wastes later on in the following webinars. So, lastly, you know, just to kind of bring this around to the finish point here on characteristic wastes, most contaminated environmental media, if they're characteristically hazardous, it's because they exhibit the characteristic of toxicity. In other words, the TCLP constituents. And I will just notice that if you're going to determine using sampling, you have to use the specified method, which is the TCLP. Some of you may be familiar with the SPLP. The SPLP, although it's suitable for certain uses, and including in remediation projects where state remediation regulations allow its use, it's not acceptable for use in hazardous waste determinations. Now let's go on and talk about listed hazardous wastes. Next slide. Okay, so the other major category of hazardous waste, in addition to characteristically hazardous waste, are listed hazardous wastes. And when we talk about listed hazardous waste, we're talking about a waste that meets a very specific material and or process definition, or as we refer to it, a listing. And there are a number of groups and or types of listed hazardous wastes. In particular, we have waste from non-specific sources. These carry an F code, or and we refer to them as F-listed wastes. So the 4-digit EPA waste code number begins with F and is followed by 3 numbers. Secondly, we have waste from specific sources, the so-called K-listed waste, which begin with the letter K. The waste code begins with the letter K followed by 3 digits. Then we have commercial chemical products, and there are U and P-listed commercial chemical products. Again, the waste codes have the letter U or P followed by 3 digits. And the difference between the U and the P-listed wastes is that the U-listed wastes are not acutely hazardous, whereas the P-listed wastes are acutely hazardous. So the P-listeds, again, are the nastiest of the nasties. These include a lot of your pesticides, very toxic chemicals, and things like certain hazardous pharmaceuticals, and so forth. Lastly, I'll just, again, point out that certain states have state-specific listed wastes. So it's always a good idea to check with the applicable state hazardous waste regulations to see if that's the case and if any of those listings apply. Let's go on to the next slide, Terry, where we're going to drill down a little further on each of the different types of listed hazardous wastes. And first, we'll start with the waste from non-specific sources. These are the F-listed wastes with codes from F001 through F039. The first ones I'll mention are the listed spent solvents, F001 through F005. There's quite a large number of solvents that are covered by these 5 different listed waste categories, but some common examples often seen at remediation sites include trichloroethylene, perchloroethylene, 1,1,1-trichloroethane, methylene chloride, MEK, toluene, and xylene. Of course, there are many others, but those are some of the more common ones. Another set of very common F-listed wastes are the metal finishing wastes, which are waste codes F006 through F019. Some common examples of these are wastewater treatment sludges from electroplating operations, and certain plating, stripping, or quenching baths. The other F codes from F020 through F039 are not very common and tend to be confined to very specific industries or sites. But they can come up from time to time. I won't go into them in detail here, but just be aware that they exist. Now, a thing with the F listings is that making F listed determinations can be tricky. First of all, the listing definitions are very specific, and you really need to read them very carefully. Secondly, the F001 through F005 listings apply not just to spent solvents that are listed in each of those listings, but to certain blends of those solvents, either within the listing or outside the listing. So that can get pretty tricky too. Although it can be difficult to read those listings and capture that, grasp that concept firmly, suffice it to say that if you have a waste that's 10% or more of one of those F001 through F005 listed solvents, or any combination of them, just about, it's very likely to be an F listed solvent. The other thing that makes them tricky is the definition of electroplating in the F006 listing, which is fairly complicated. Again, I won't go into detail in this presentation, but just suffice it to say that there are certain specific processes that fall under the definition of electroplating, and some that might seem like they should that don't. Just to hone in a little bit further on some of these tricky aspects, the F001 listing, which is for certain spent solvents, halogenated solvents in particular, used in degreasing, it has to meet all of those criteria. So in other words, first, it has to be spent. If it's not spent, it's not F001. Secondly, it has to be one of the listed halogenated solvents in the F001 listing. If it's not, then it's not an F001 solvent. Lastly, it has to have been used in degreasing. If it was used for something else, it's not F001. The F002 listing contains many of the same chemicals as in the F001 listing, but it doesn't specify that the chemicals have to have been used in degreasing. It just applies to certain spent halogenated solvents. So if they're spent and they're one of the listed halogenated solvents, they fall under the listing. If they're not spent or they're not one of those listed solvents, they don't fall under the listing. And similarly, the F006 listing only applies to sludges from wastewater treatment from certain specified electroplating processes. So A, if it's not a sludge, which is to say a treatment residual from the treatment of a wastewater, and it's not one of the specified processes, then it's not a FU6. I'll also note that the F006 listing doesn't apply to plating baths or other wastes associated with electroplating. It just applies to sludges from the treatment of wastewaters from electroplating. However, waste such as baths could fall under the F007 through F011 listings, and any of these kinds of wastes generated at electroplating sites could be characteristically hazardous. Next slide, please. Okay, listed hazardous wastes from specific sources. These are denoted by EPA waste codes K001 through K181. A little too far there, Terry, thank you. They're called waste from specific sources because as opposed to just general categories like spent solvents or solvents used in degreasing, oftentimes the specific industry is specified. Or a specific process within a certain industry, and oftentimes a specific chemical within a certain process within a certain industry. And the specific industries covered under K listings include wood preserving, the manufacture of inorganic pigments, organic chemicals, inorganic chemicals, pesticides and explosives, petroleum refining, the iron and steel, primary aluminum and secondary lead industries, the production of veterinary pharmaceuticals, ink formulation, and coking. So the waste streams are listed out by industry sector, so it's, you can usually hone in really quickly, but some of the more common K-listed wastes that we see in the NMOA states include wastes from steel manufacturing, in particular KO61 steel mill flue dust, which is typically captured in air pollution control equipment at steel mills, and KO62 spent pickle liquor from steel finishing operations. As indicated, most of the rest are not very common. And also, the K listings tend not to be as tricky to interpret as the F listings because they are very specific. It is still important to read them very carefully, but they are very specific to the industry, the process, and the chemical. Let's move on to the next category of listed hazardous waste, which is commercial chemical products. These are the so-called U and P listed wastes, which is to say that the EPA waste code for all of these starts with either a U and 3 digits, followed by 3 digits, or a P and followed by 3 digits. These are limited specifically to discarded commercial chemical products and manufacturing chemical intermediates that are listed in the U or P lists of chemicals. So the U and P lists specific chemicals, sometimes groups of chemicals. It also includes, in addition to the actual discarded commercial chemical products, spill and container residues of those commercial chemical products. And oftentimes in a remedial context, it's spill residues that come into play that might make something make a remediation-derived waste, such as a sediment, a soil, or groundwater, a U or P listed hazardous waste. Now, in order to fit under these commercial chemical product listings, the chemical must have been unused. If it's been used, it might fall under one of the F or K listings, or it might be characteristically hazardous, but it wouldn't be a P waste or a U waste. In addition, it has to be the commercially pure grade of the chemical or a product which contains the chemical as the sole active ingredient. So sometimes, as an example of the latter, sometimes you'll have a pesticide, for example, which might only contain 1% or less of the actual pesticide constituents, and the remainder is solubilizing agents, carriers, etc. In that case, this would be an example of sole active ingredient, because those other ingredients, although they're present, they're not the one that performs the function of the product, which is, in the case of a pesticide, to control pests. Some examples of U and P listed wastes. Many of the unused solvents listed under the F001 through F005 codes have a U code counterpart. So, for example, unused 1,1,1-trichloroethane is EPA waste code U226. TCE is waste code U228. PCE, perfluoroethylene, is waste code U210. Methylene chloride is waste code U080. MEK is waste code U159, and so on and so forth. There are a number of them that are also have U codes and fall under the commercial chemical product category if they're unused. Similarly, some of the pesticides and herbicides in the TCLP list also have U or P counterparts. So, for example, chloridane is U036, endrin is PO51, heptachlor is PO59, lindane is U129, methoxychlor is U247, toxaphene is P123, and 2,4-D is U240. It's important oftentimes, if there have been spills of virgin chemicals at a particular remediation site, to take that into account when performing hazardous waste determination on any media that may be being generated. On to the next page. Now, an important issue or concept with respect to listed hazardous waste as it applies to environmental media is something that is called the contained-in principle. Now, I'm going to contrast the contained-in principle as opposed to the contained-in policy. The two are different things. The contained-in principle, as noted here in the first bullet, is just the concept that contaminated environmental media that contains a listed hazardous waste is itself regulated as a listed hazardous waste, at least after the point of generation. So the media itself, the soil, is not itself a hazardous waste, but it has to be handled as a hazardous waste because it contains a listed hazardous waste. That's the contained-in principle. In a later webinar, we'll talk more about something different called the contained in policy, under which certain contained in media can be quote unquote contained out or not considered to contain listed hazardous waste when they meet certain criteria. Again, that's a topic for the next webinar. One thing about the contained in principle to keep in mind is it applies only to listed waste. It doesn't apply to characteristic hazardous waste. If you remember back when I talked about media contaminated with characteristic hazardous waste, I said that media, those kinds of media are hazardous only if they themselves exhibit a characteristic of hazardous waste. So this is different. Contaminated environmental media doesn't necessarily have to have a listed hazardous waste present at any certain concentration in order to be hazardous. Just by merely containing it, it makes it necessary to manage as a listed hazardous waste. Now, some examples of contained in waste that you might encounter at a remediation site include, for example, the first bullet there, soil contaminated with electroplating wastewater sludges. So in that case, the soil would have to be managed as an F006 waste by virtue of the fact that it contains those electroplating wastewater sludges. Second example, groundwater contaminated with spent perchloroethylene dry cleaning solvent would have to be managed as an F002 waste because it contains a listed hazardous F002 waste. And lastly, sediment contaminated by a release from a tank of virgin xylene, which carries waste code U239, would have to be managed as a listed hazardous waste because it contains a U-waste, commercial chemical product that was spilled. Next slide, please. Now, this will come up again in the next webinar when we talked about the contained in concept, but there's some important concepts here with respect to characterization that help solve some dilemmas that can come up. The first sort of dilemma is, what if you don't know what the source of the contamination was? In other words, whether or not the source was actually listed, fell into the listing. What EPA has said, and what I believe most states in the NMOA region concur with, is that if, after good faith efforts to determine whether or not the media is contaminated with a listed hazardous waste from a listed source, just documentation confirming that is unavailable or inconclusive, it's not necessary to assume that it's contaminated with a listed hazardous waste and therefore has to be managed as a listed hazardous waste. Secondly, what if you don't know when the contamination happened? Remember, we talked about effective dates of RCRA, and that a waste that is put into storage or disposal before the effective date of RCRA doesn't become a waste, isn't generated until it's removed from storage or disposal. Well, it turns out EPA has said that you can use a similar approach here, which is to say, if after good faith efforts to determine the date that the contamination occurred with the listed hazardous waste, it's not possible to determine that date because documentation is unavailable or inconclusive, it's not necessary to assume that the contamination is listed and that the media is already a hazardous waste. Now, keep in mind, once it's picked up, once it's excavated, it becomes generated, and then it would become a listed hazardous waste. But as we'll discuss in future webinars, you know, in some circumstances, it can be very beneficial not to intentionally not generate a remediation waste and to either through treatment or through testing render it non-hazardous prior to generation. Now, when I talk about good faith efforts to determine what the source of the contamination was or when it occurred, what we mean here is that you really have to try to find the answer. A couple of examples. If you find perchloroethylene at a former dry cleaner site, but there's no records of any spill, you know, it's pretty safe to assume that you've got an F002 listed hazardous waste on your hands. Possibly a U210 if it was virgin product that was spilled, virgin PCE that is. But, you know, with the existence of the dry cleaner site, we know that they use PCE. I think the preponderance of the evidence at that point would have to be that the PCE found in environmental media at the site came from a listed source and therefore is itself listed. A second example, let's say you find ethylbenzene, toluene, and xylene at a former gasoline depot. You do some research and you found that the gasoline depot never used solvents, they didn't do degreasing, and basically you can't find any confirmation that they even ever purchased the stuff. And that would be an example of a case where it might be appropriate to assume that this particular environmental media is not an F003 or F005 waste, which those solvents fall under if they're used as solvents. And in particular, the other thing is that benzene, ethylbenzene, toluene, and xylene are all common constituents in gasoline, so it's not a surprise to see them at the site at all. Let's go on to the next page. I'm going to go over some resources here for determining listed hazardous waste codes. A big one is manifest data. Manifest could be obtained from the property owner or the operator. For example, somebody leasing the property that might have operated a business there. They can also be found via state and federal databases. For instance, the state of Connecticut recently underwent a massive scanning project to scan, I think we've now got almost every manifest we ever received into that system and available for viewing in a searchable format. Other states have similar resources that can be used to find manifests. And now, for the past couple of years now, we've been under the so-called e-manifest system where EPA has basically taken over the archiving of manifests in an electronic database that's accessible and searchable. One thing I'll caution about manifests data is that not all hazardous waste codes are necessarily listed on the manifest, and that can be for any number of reasons. It could be that the generator didn't perform a proper hazardous waste determination and might have missed some codes. It might also be that they neglected to put some of the codes on there. And more recently, with the e-manifest, there's only a certain number of spaces for codes. So if you exceed the number of spaces on the e-manifest, there may be codes that are left off. Some generators will put the additional codes in box 14 of the manifest, but not everyone does that, and it's not required to do that. Another source of information would be state and federal agency inspection reports, such as hazardous waste inspection reports, water or air inspection reports. These are useful because they identify chemicals that might be at the site, processes, so on and so forth. Other resources can include company records, interviews of former employees, physical site visits. I mean, if you go to the site and there's still a building there and you see a plating line or a degreasing unit, then you have a pretty good idea that there was electroplating and degreasing going on. Also, town records can be available, that might be available, that could be of help. They can provide information about materials that might have been used or certain processes that might have been, occurred at the site. In addition, when it comes to the regulatory side of things, you have a particular EPA guidance document that I've got a link for there at the bottom of the page. That's similar to the one for characteristically hazardous waste that I noted earlier, but it's specific to listed hazardous wastes and goes over some of the issues I talked about, such as the listed solvent of F001 through F005 listings that can be kind of tricky, and the F006 listing for electroplating wastewater sludges. Also, there's an EPA webpage that I have a link for there that's also a great resource for this. Next slide. I'll just quickly note that there are some exemptions from hazardous waste requirements that can apply, not very often, but they can apply in certain cases to remediation wastes. The first example here, or the first type exemption listed here, are characteristic sludges, byproducts, and commercial chemical products that are being reclaimed. And you'll note in each of these, I'm citing the federal citation. Each state in the NMOA area may or may not pick up all of these exemptions, so it's always a good idea if you're trying to avail yourself of one of these exemptions to check to make sure that the state adopts it. So this first one, as I said, is characteristic sludges, byproducts, and commercial chemical products that are being reclaimed. An example of this might be, for example, if you went to a site that had a surface impoundment, they were a metal finishing site, they had a surface impoundment that had been removed previously, but you're doing excavation at the site and you find a vein of sludge in the ground, and it turns out that that sludge is very high in zinc, high enough to the point that it could be reclaimed for zinc. Then you could send that vein off to a metals reclaimer under this exemption. It would not have to be regulated as a hazardous waste. The second bullet and the second exemption I'll discuss here briefly is the so-called fuel-to-fuel exemption. Basically, what this exemption says is that if you have a waste that is hazardous and is a fuel, it's not subject to regulation. It's exempt if it's being sent to be burned as a fuel or processed into a fuel. This is a useful exemption oftentimes for gasoline-free product, contents of gasoline tanks, and other concentrated fuels that can be readily either used as fuels directly or processed and blended into waste-derived fuels. The third example here is the domestic sewer and point source discharge exemptions under RCRA, which apply to the actual discharge subject to the Clean Water Act. And I will note that that almost always means that there's a permit involved. Some states do. Connecticut, for example, issues permits to domestic sewer. Not all states do. Sometimes it's the local sewer authority that issues those authorizations. And this could apply, for example, to groundwater pump and treat system wastewaters that are pulled out of the ground, perhaps treated, and then sent to domestic sewer or a permitted point source discharge under the Clean Water Act. Another example is household hazardous waste. Doesn't come up often, but if you're at a remediation site that happens to have a residence on it, and that could include anything from a single-family residence to a hotel, it's possible that waste that those residents left behind could be managed as household hazardous waste. Another one is ash and other residues from the combustion of fossil fuels. That is specifically exempt from regulation. The next slide has some more exemptions that might apply. This first one is can be quite commonly used, and it applies to petroleum contaminated media and debris from underground storage tank cleanups conducted under the federal underground storage tank cleanup program, or it's the state equivalent. This was done specifically to help facilitate the cleanup of underground storage tanks and not create a disincentive to cleaning up those contaminated sites. The second example is environmental samples of waste, water, soil, or air. There's a specific exemption from them while they are being collected, transported, and actually sampled at the laboratory. Once that process is complete, the exemption is no longer in effect, and if the material is hazardous, it has to be handled as such. Another exemption that exists is scrap metals. Oftentimes at remediation site, you come across scrap metal materials in the ground or on the site. They, even if they might, for example, lead scrap might otherwise be hazardous, they can be handled as non-hazardous waste if they're sent for scrap metal recycling. And I note there that the scrap metal exemption it has a restriction, or it isn't spelled out in the regulation, but EPA's long-term interpretation of it is that it does not include scrap metals that contain liquids or that are in liquid form, and that would include things like elemental mercury or scrap metal items that contain significant amount of liquids, such as equipment with chemicals or oil inside of it. The last one on this page, and Terry, if you could just hit the return button 2 more times to get the last 2 little bullets there, is the empty container exemption, which indicates that empty containers that might formerly have contained hazardous waste or a chemical that was hazardous don't have to be managed as hazardous waste, provided they meet the conditions specified in the regulations. First, all liquids that can be removed from the container by the normal methods have to have been removed. And secondly, after that has occurred, the container must contain less than 3% by weight of residue or 3 inches. And again, I reiterate that first and foremost, all the liquids that can be removed from the container must have been removed. Now, this standard is different for acute hazardous waste, and this is one of the reasons why it's important to note whether or not in a waste determination you're dealing with an acute hazardous waste. It turns out that the empty container exemption for acute hazardous waste requires either triple rinsing of the container to remove as much of the residue as possible, or if the container had a liner in it, removal of the liner and disposal of the liner as a hazardous waste. Let's go on to the next slide, which is the last set of exemptions from RCRA. Waste that are reclaimed for a significant amount of precious metals. So if you happen to have a site that engaged in precious metals manufacturing or used precious metals in plating or whatever, it's possible that some of the wastes, some of the residues or remediation-derived waste might actually contain significant amounts of precious metals that might make them reduced, subject to reduced, not completely exempt, but reduced requirements for precious metal recyclables. The second one is, again, a reduced set of requirements for hazardous waste that are recycled. It's a common misconception, and I run across this a lot, that hazardous waste that are recycled are exempt from RCRA. As noted previously, there are certain types of hazardous waste that are exempt from RCRA when they're recycled, but they're not exempt merely by the virtue of being recycled. They have to be recycled in certain ways to be completely exempt. If they're recycled in some way other than the specific specified ways I've mentioned earlier, there are certain exemptions for the recycling process, and in particular the facilities that recycle those materials. But other than that, they have to be handled the same as regular hazardous waste. And lastly, there are certain wastes that aren't exempt but are subject to special and often streamlined or reduced requirements, and that includes things like used oil, which contains materials containing or otherwise contaminated with used oil, which can include contaminated soil and contaminated groundwater. And secondly, universal waste, i.e. batteries, certain specific pesticides, mercury-containing equipment, fluorescent lamps, and certain other state-specified wastes, for example, in Connecticut, used electronics. Going on to the next slide. So we've gone over the process of, determining when a waste is generated, determining whether or not it's hazardous. And if you've gotten to the point where you've done all of that and you've determined that the waste is not hazardous, you have to keep in mind that even though the contaminated soil or sediment or the waste is not hazardous, it could still be regulated as a solid waste. Some states will classify contaminated soil, for example, as a special waste and restrict where it can go. They may also have permitting requirements for the facilities that receive those wastes, such as landfills and soil burner facilities. In addition, the state remediation standard regulations might apply. For example, in Connecticut, our remediation standard regulations have a specific provision for the reuse of polluted soil. And use as fill material on or off the site might be restricted or might require special approval by the state. And a great resource on this, which is identified in that last bullet, is NMOA's soil reuse webpage, which has some state-specific information on the reuse of polluted soil in NMOA states. Next slide. In addition to regulation as hazardous waste or potentially solid waste, some other contaminants that you always need to keep in mind when characterizing environmental media include the following. First of all, PCBs. PCBs are not regulated under the RCRA hazardous waste requirements, but they are regulated under TSCA and corresponding state regulations. So if you've got PCBs at the site, they could potentially be subject, or the media could be subject to both RCRA and TSCA requirements, or just one or the other, depending on what is present and in what concentrations. Another one is asbestos. If you have asbestos at the site, it may be subject to regulation under the federal NESHAPS requirements, depending on the form it's in and where it's found. It could also be subject to certain state requirements. For example, in Connecticut, we regulate asbestos as a special waste when it's present over certain concentrations. And lastly, there's always emerging contaminants. A big one right now that all of us really are looking at, and especially New York, New Hampshire, and Vermont, are PFAS compounds. So, you know, although EPA is oftentimes a little slow to catch up and list these emerging contaminants as hazardous waste, states often will impose restrictions on the management of environmental media contaminated with these emerging contaminants, as several states in the Namur region have done for PFAS compounds. Going on to the next slide, we're going to get into some examples here. The first one, and these are just kind of general scenarios, and what I'll do is I'll just read the scenario and then I'll pause for a moment to give you some time to think what you think might be the answer, i.e., is this a hazardous waste, and if so, what kind of a hazardous waste? So let's look at the first one. Let's consider a soil that's contaminated with lead from a non-listed source at a concentration in the soil of 6.5 milligrams by TCLP. Would that waste be a hazardous or a non-hazardous waste? Think about that for a moment. The answer on that one is pretty straightforward. The TCLP limit for lead is 5.0 milligrams per liter, so 6.5 exceeds that. So that soil would be a characteristically hazardous waste and would carry the EPA waste code D008 for lead. And I'll say at least after the point of generation. If we had a situation where that waste was disposed of pre-November 19th, 1980, it wouldn't actually become a waste until it was picked up. Scenario number two. In this scenario, we're considering soil from the site of a dry cleaning business that operated from 1957 to 1973 that is contaminated with perchloroethylene. Is that a hazardous waste or is it not a hazardous waste? Think about that for a minute. Okay, in this one, due to the date of the contamination, which is before November 19th, 1980, it would not be a hazardous waste while it's in the ground, but at the point that it's picked up, at the point that it's generated, it would, at that point in time, become an F002 hazardous waste via the contained-in principle. That's assuming that the PCE that's there in the soil was used before being released. If it was the result of a spill of virgin PCE, it would also be a listed hazardous waste, but the appropriate code would be U210 for PCE, not the F002 listing. If, and I suppose this could happen, if it were determined that it was neither from used dry cleaning solvent or unused, it could still be a characteristically hazardous waste because the perchloroethylene is listed on the TCLP list as hazardous in concentrations over 0.7 milligrams per liter. I'll also note that if this waste were either an F002 waste or a U210 waste, there would be no need to also list the DO39 code on the manifest or to characterize it also as a DO39. There's a general principle that if a listed hazardous waste also exhibits a characteristic for a constituent that it was listed for, it doesn't have to also be identified as a characteristic hazardous waste for that constituent. Okay, the third scenario. In the third scenario, we have groundwater from a monitoring well, okay? And that groundwater is contaminated with virgin MEK from a 2005 tank spill. Okay, think about that one for a second. Now, in this case, we have a situation where the release of the MEK occurred after the effective date of RCRA, which was November 19th, 1980. So as a result, that was hazardous waste as soon as it hit the ground, and it's still a hazardous waste in the ground now. So the groundwater that's pulled out, say, from the monitoring well, would be subject to regulation as a listed hazardous waste, specifically U159, which is the listing for MEK, virgin MEK, because it contains virgin MEK. Number 4, and let's see, Terry, could you hit the return button one more time, because there's a 5th one that shows up there. Okay, number 4. In this case, you have some woodblock flooring from a metal fabricating company that did degreasing using chlorinated solvents. Think about that one for a second. Would that be hazardous or non-hazardous waste? In this case, the answer here is you don't know for sure, but the fact that they did degreasing using chlorinated solvents raises a red flag and indicates that the floor may have become contaminated with listed degreasing solvents that would fall under the F001 waste listing. As a result, it would be appropriate to test the woodblock flooring to see if that's the case, and if it is the case, handle it as a listed hazardous waste. This is, I didn't make this one up. This actually occurred a number of years ago, and unfortunately, a consultant removed about 3,000 cubic yards of this material before realizing that some of it was contaminated with chlorinated solvents, and the material all got mixed up by that point in time. He wasn't able to segregate the section that was contaminated, and all the stuff had to go off-site as hazardous waste. The 5th one is, the 5th example here is some contaminated soil, piping, and tree stumps generated during the cleanup of a gasoline underground storage tank that's conducted under the federal underground storage tank cleanup regulations, or the state equivalent. Would that be hazardous or non-hazardous? Okay. The answer here is that as a starting point, these wastes could be hazardous due to contamination by gasoline, in particular because gasoline contains benzene. Benzene's on the TCLP list. However, they would be eligible for exemption from the hazardous waste requirements for that exemption I mentioned just a few minutes ago for contaminated media and debris from UST cleanups conducted under either the federal UST cleanup program or the state equivalent. So those could be handled as non-hazardous waste as a result. Terry, in the interest of time, I think I'm going to pass over the next examples. The slides that Terry will be posting have all the answers posted on them, so you can always go back and read those later. I intentionally had actually more examples than I thought I might have time to get to here, just because I thought that that would make this more useful for use after the presentation. The couple of last things I just want to hit on real quickly here before we finish up, and hopefully have a little time for Q&A. As I mentioned before, one of the things that we like to hammer home is that waste characterization of whether it be contaminated environmental media or any waste that might be generated during a remediation project should be an integral part of the site-wide project management. In particular, it should be part of it from the very beginning stages of investigation and project design, and certainly well before work starts. I understand that it's very tempting when you're doing a site cleanup to focus on the cleanup aspects of the project and worry about characterization later. You know, look, I've got contaminated soil here. I just want to dig it up, put it in a pile, and worry about what to do with it later. The problem with that kind of thinking is that it allows the law of unintended consequences to kick in. And unfortunately, this can result in non-compliance, which in turn can result in enforcement actions or penalties, or unexpected need for certain approvals or permits that you weren't anticipating, and unnecessary delays and cost overruns. So, you know, if you take into account waste characterization and waste management from the very beginning stages of the project, hopefully you can avoid these unintended consequences. In addition, if you begin work before you've really characterized material and you know what you're dealing with, you also miss some opportunities to minimize disposal cost. In particular, it might mess up the timing of so-called contained in determinations. which again we'll talk about in the next webinar, which is a way that you can, through testing, demonstrate that a material that might otherwise be regulated as listed hazardous waste, such as contaminated environmental media, actually is at such a low concentration that it doesn't need to be regulated as a listed hazardous waste. Other opportunities that can be missed as a result of not considering waste characterization early enough in the process is issues having to do with contaminated soil management, such as in situ or ex situ treatment and staging. So as a result, one thing that we encourage people to do is, consider including a RCRA expert specifically as a key member in the project design. Oftentimes, the person in charge of a remedial project is a geologist or hydrogeologist that may be licensed. We have licensed environmental professionals in Connecticut. Other states have LSPs. And they're usually the ones leading up the investigation, but it's really a good idea if you have a site with any significant contamination, particularly if it could be RCRA related, that you get the right kind of expertise. And if you could just hit the last two buttons, Terry, and this expertise could be in-house or it could be contracted out, but that's what we recommend. So if we go to the next slide, which is the last slide, I just want to point out here that, as I said earlier, we gave some in-person training provided earlier this year, which was sort of an overview of remediation waste management. Those three presentations that were given in May and June are all available on the MOA website via that link. And the webinar we're doing today is the first of 4 webinars that will provide more detailed information and expand upon the presentations that were given back in April and May. And in particular, the remaining 3 webinars will address the area of contamination and contained in policies. That's going to be on November 13th. And we're also, early in the new year probably, we haven't set the dates yet, we're going to do separate webinars on waste piles and on waste treatment and land disposal restrictions. If any of you have thoughts for other ideas that you'd like to hear about, other topics, let us know, and we'll take it into consideration and try to see if we can't fit it in. And with that, Terry, I don't know how much longer we have access to the webinar site, but if anybody has any questions, I'd be glad to try to answer them in the available time.
Thank you so much, Ross. That was very comprehensive and covered a lot of territory. We do have some questions that participants, I think the echo may be coming from your end, Ross, but I'll try to get through these questions. Tamara Schulten asks, do RCRA 90 days limit apply to soils that have listed hazardous waste?
Okay, the answer would be yes, at least after the point of generation. That's why the point of generation that I described in there is so important, because that starts the 90-day clock ticking. And I say 90-day with the assumption that you're talking about large quantity generator amounts, right? Because small quantity generators have a limit of 180 days. But yes, that does start the clock ticking.
Great. I just want to say I want to recognize that we are at the time end of the webinar, but hopefully folks can stay a few more minutes since we started late to get through some of these questions, because I think we've got some good questions here. Also from the same person, the question is, for the 20 times rule for a soil stockpile, can you average the total constituent concentrations, or must you use each individual total result?
Okay, that's actually a really good question, and it's a difficult question to answer succinctly, because there's kind of 2 issues at play here. One of the issue is representative sampling, which I mentioned earlier. Waste streams, any waste stream, whether it be contaminated environmental media or just an industrial waste, some of them are highly heterogeneous. So they're going to vary from spot to spot. So you often need to take multiple samples in order to account for that. However, the other thing that's at play here is the concept of hotspots. EPA has said that if you have an area of dispersed contamination. And within that area, you have distinct, discrete hotspots that are at higher concentrations than the remainder of the dispersed contamination. You have to treat those hotspots separately, remove them as hazardous waste, and then deal with the remainder of the media as non-hazardous waste. Now, my recommendation here would be, because this can be very site-specific, would be to coordinate with your local, with your state or environmental agency if you have questions involving this issue, because it can be very site-specific and it can be very tricky.
Thanks, Ross. So the next question is a sort of a big one. Can you explain the opening, quote, general principle for contaminated media or waste in the ground in regard to hazardous waste disposal of into the ground or spilled into the ground after its effective date of being listed or designated a hazardous waste? Is this type of waste or contaminated media considered hazardous waste when in the ground and before excavation because it was hazardous before disposal or at the time it was spilled, discharged, or became a waste?
Long question, simple answer, yes. If it was hazardous waste at the time it was spilled, it remains a hazardous waste in the ground. And sometimes, you don't know that it's there until you're doing the site remediation. You found, wow, they spilled this waste back in 2005. And either they didn't know that they had spilled it because there's an underground pipe that ruptured or something of that nature. But nevertheless, it would be a hazardous waste in the ground and at the time of excavation.
So the next question is, are there situations where a waste solvent would not be considered, quote, spent?
Yes. The simplest answer to that is if it's virgin solvent, even if it's spilled virgin solvent, then it still falls under the commercial chemical product listing. So if I gave an example with virgin xylene in a tank. If that tank springs a leak, then any soil or groundwater contaminated by that leak is contaminated by a commercial chemical product listed hazardous waste. Where things get a little fuzzy is when you have solvents that have been used but aren't completely spent. That's really more of an issue for industrial waste characterization purposes, but I'll just say that EPA has said, most states agree, that a solvent doesn't have to be completely spent in order to be considered spent. If it has been used at all and it's being discarded, then it's considered a spent solvent.
Okay, on to the next question. For determining if a listed waste applies to a soil using testing, is it based on a presence or absence, or is there a concentration in the soils that would be considered not listed?
Okay, that really gets to the issue of, well, let me answer the question first in the general, and then I'll get to the specific. The general is, if you have any detectable concentration of listed hazardous waste, then your media contains a listed hazardous waste. And obviously, that's a pretty stringent starting point, right? Because it loops in a lot of material that's at very low concentration, maybe even below what's allowed as a cleanup standard. That's why, and we'll talk more about this in the next webinar, there's this thing called the contained-in principle, that if concentrations are low enough, i.e. below health-based limits set by states, they can be considered to no longer contain listed hazardous waste and therefore not a listed hazardous waste.
Okay, this is the last question I have, and I think I might, this person, Tamara, has asked a bunch of questions, so I might unmute her, see if that'll work. But she asks, is IDW exempt from hazardous waste requirements?
Okay, so by IDW, I'm assuming she means investigation-derived waste. EPA has put out guidance regarding investigation-derived waste, and it's also discussed in various documents associated with the Superfund program. But suffice it to say that generally speaking, investigation-derived wastes don't benefit from any particular exemption from hazardous waste requirements. So in general, investigation-derived waste, and by investigation-derived waste, we mean things like soil samples, drill cuttings, water from bailing out, drinking groundwater monitoring wells, and materials like that. Generally speaking, they're subject to characterization and management the same as any other hazardous waste.
Okay, I have unmuted Tamara. Did you have anything you wanted to follow up with since you've asked a bunch of questions?
Thank you very much for your time, and I appreciate the opportunity to ask these questions. And on that IDW question, does that apply if it's a CERCLA investigation as well?
Okay, I mentioned CERCLA for a reason, and it's because CERCLA is a special animal, right? So when you're dealing with a Superfund cleanup, then you've got RCRA is an ARR, right?
Right.
So, and you know, how you deal with ARRs will vary from one project to the next, right? So, for example, under the context of a CERCLA cleanup, or I should say a Superfund cleanup, you might be doing some treatment or some soil management that might not strictly be allowed under RCRA, but if it goes into the remedial action plan as part of the Superfund cleanup, it can actually occur under the authority of CERCLA, even though it might technically not be in compliance with RCRA regulations.
Thank you.
So I think we've run out of time and we're starting to lose people, Ross. But again, I want to thank you for your presentation this morning, and I want to apologize for our late start and some of the technical difficulties we had in the beginning, but I think after we got going, things went pretty smoothly. I will let folks know when we've posted these presentations on our website and where they can find them. And please join us for the next webinar, which Ross mentioned will take place in November. Thank you, everyone, and have a good day.
Hey,
Bye.
Terry?
Yeah?
Terry?
Yes?
Just quickly, were there any other questions that came in?
No. That was all the questions we got.
If you want to, you can send me those questions, and I can prepare answers to them as a supplement to this.
Okay, if I can figure out how to do that, I'm pretty sure there's a way to do that, and we'll try to do that. Thanks, Ross. We'll be in touch.
Okay, thank you.
Okay, have a good day. Bye-bye.
Bye.